Hey guys, thanks so much for joining us this week for this week's episode of When I Grow Up. Today I'm interviewing a geotechnical engineer who happens to also be my cousin. His name is Alex Hum. Hey Alex, how are you?
I'm doing good, Blair. How you doing?
I'm doing well, and I'm so glad that you agreed to do this with me because if you are new to the podcast itself, you've probably remember in previous weeks and previous episodes, I've had two of my cousins on already, the NAUSA, Alicia, and also a chemical engineer, Dr. Tony Hum, who is Alex's older brother. So if you're new to the podcast, I am the youngest of 5 cousins on my dad's side. And I've mentioned before, all of my cousins, amazing people doing amazing things.
I don't know about that.
Yes, no. I am a little different than my cousins because they're all really smart and super studious. And they're all the males at least are engineers in our family. Fun fact. And I feel like at this point, including my husband's also an engineer, and my dad and our dads, all of our dads. And at this point, I feel like we've covered all of the engineering not all of them, but a lot of them. But again, today, Alex is going to tell us what a geotechnical engineer does. So Alex, what does a geotechnical engineer do?
Well, thanks for the introduction. We'll come back to the studious part maybe a little bit later and dispel some of those rumors. But a geotechnical engineer is a branch of civil engineering. In the shortest terms, we deal with earth and soil, the engineering properties and use of earth and soil, rock, soil, everything we build in this world, every road, every structure, every building, every utility we put in, everything we do is founded in the earth somehow. It has to be supported somehow. So in order for anything to work properly, in order for our roads to be straight, our buildings to be stable, our utility lines to flow the right direction, the earth around it has to be engineered in a way to provide proper support. So everything I do is quite literally underground. For the most part, nothing you see is any work that I do. Everything we do is support, it's base. It's really all about, for the most part, all about foundations. So it's really just the support structure for all of the infrastructure that makes the world go, basically.
Okay, so that's kind of crazy only because there are so many things I know that go into creating and making buildings and structures. And I know this because my husband is a structural engineer. Dave is a structural engineer, which is also, from what I understand, a branch of civil engineering.
Yes.
So there are many things that have to happen in order for something to get built. It has to go through a lot of different people. And I'm assuming and I'm guessing that if you say no to something and it can't be built there, it can't be built there, right?
Yes. Yes. If I say no, it can't be built there, the answer is either, there's almost always a way to make sure it can get built. It may be more expensive than what the original plan was. But you can almost build anything anywhere if you're willing to spend the time and money for it. So part of my job is to assess the area that's there, that they're saying, hey, we want to put a building right here. It's going to be a 5-story building with a 2-story parking garage underneath it. My job is to go out before any construction is done, before any equipment goes into the ground, to go to a site and evaluate that site based on what they plan to build there. So I can tell them, okay, well, this is what you want to build. Here's what you're going to have to do to the ground, to the surface, to the earth, in order to provide support for what you're trying to build. And if what's there isn't any good and it can't support that, part of my job is to say, well, here are your options, what you can choose if you still want to build on this site. So, here are the other options besides just a kind of a typical foundation, which, anyone in construction, if you tell them what are called shallow spread foundations, a shallow footing is your typical just concrete footing. It's about 3 foot in the ground. If a site is beyond that and it needs some sort of very specialized or specific kind of recommendations for it in order to get this building built. It's my job to tell them it's not my job to tell them what they have to do.
Mm-hmm.
It's my job to give them the options. Here are the things you have to do, A, B, C, and D.
Mm-hmm.
These are your options that are in front of you. And then they decide based on whatever their economic situation is, their time frame is, things like that. There are times where you go back to a client and say, this is what you have to do.
Mm-hmm.
And it's so expensive that they just say, no, we're going to walk away, and we don't build the building there because the site's so bad. That's rare. That's rare because typically if you're at the point where you're saying we need to build something here, you're committed enough to do whatever it takes. They're not happy when they have to, add, extra cost to their budget.
Sure.
But if that's what it takes, that's what it takes.
Okay, so as a geotechnical engineer, you are surveying the ground and the land,
Mm-hmm.
which, by the way, I had no idea this job existed, but of course it does. Like, how does
Most people do, yeah.
like, I mean, but that makes complete sense, But so how do you even get started? Like, what kind of assessments have to be made? And like you were saying, there are some times you tell them, you can't build here. Like, what determines that?
What determines that is what's already in the ground now, like the condition that it's in.
Mm-hmm.
And we assess that basically by doing some sort of subsurface exploration. Typical explorations are what are called standard penetration test drillings.
Mm-hmm.
Basically, we drill a hole in the ground, a vertical hole about 6 to 8 inches in diameter, and the drill is hollow.
Mm-hmm.
And so as we drill down to a certain depth, we can sample the soil through the drill itself. So we can
Mm-hmm.
drill down to 5 foot, 10 foot, 50 feet, 100 feet, whatever it is. And there's a specialized soil sampler that we literally pound into the ground. And this is it's all standardized. So the amount of weight, which is 140 pounds, and how far you lift this weight up and drop it down on the sampler, which is 30 inches, that weight and that distance, depending on the number of times you have to drop this weight on the sampler for it to advance into the ground,
Mm-hmm.
that number of blows, so if it only takes 3 blows, it's pretty soft. If it takes 45 blows, it's a lot harder. All of those have standard correlations back. We have charts and things like that. So that gives us an initial assessment of what the ground looks like.
I see.
Then from there, we can take those samples, and then there are other ways to get samples, but so we have field measurements that tell us what we can see while we're collecting samples. Then we can take those samples back into our laboratory and run a number of other tests on them, tell us the exact type of soil, the makeup. There are 4 basic divisions of soil: gravel, sand, clay, and silt. Depending on the percentages of each one of those types, we can get a sense of how the soil is going to react, how strong it's going to be. And a lot of that just comes from experience and knowledge. But basically, we have to know what's in the ground, A, what's in the ground, and B, what condition it is in the ground, to give us a sense of how that's going to react when you put a load on it.
Mm-hmm.
The other thing that we're going to have to look at, because it may not be the building itself, if a site is, let's say it's really hilly or it's sloped in a certain way, and you have to change the geometry of the ground by cutting and filling and moving soil around, that also changes what's going to be supporting the building. If you have a site that you need to raise up 8 feet before you can build it, let's say you're trying to match the roadway. So you have a flat driveway in, but your site is 6 feet below the road.
Mm-hmm.
You got to bring your whole site up first before you build anything. So the natural soil there is not specifically supporting the structure you're building.
Mm-hmm.
It has to support all the new soil that goes on top of it.
Right. Okay.
So knowing that ahead of time is important. And this is where the more information I have to begin with, like how much design has been done, what kind of building, what the grading is going to look like, is important, because that changes my plan for investigation. Because a structure and a specific footing, is going to have what's called a zone of influence. Basically, the soil that it's resting right on is going to take the most amount of load, the most amount of weight. And as you go deeper beneath that specific point, it's going to dissipate less and less till you get to a point where the ground is no longer influenced by the weight that it's on. So I need to know how much fill is going to go in or how much natural soil is going to be there to make sure I get deep enough so I can analyze enough soil, basically. Because if I just look at the top 10 feet, but the building is going to be 8 stories, well, an 8-story building has a zone of influence that's way deeper than 10 feet. So just knowing the top 10 feet isn't important. I need to know probably 40 or 50 feet. So that all depends on what you're building, what the end use is going to be. So what happens a lot of times is because we're brought in, in a perfect world, we're brought in very early on before any work is done, because you want to look at a site first. But oftentimes we're brought in before anyone's done any real design work. So they don't have a specific plan. They don't know exactly where the building is going to go. They don't know exactly what the layout is. They don't know exactly what the design is going to be. So oftentimes we'll come in and just do a preliminary analysis and say, here's what the site looks like. And then if they get that information and then they figure out what their design is, we'll come back again on the same site and do additional investigation. So a lot of times we'll look at a site twice. Once just to say, hey, here's the kind of soils you got out here. This is what you're generally dealing with. And that can help them sometimes with their design. And then once they have, okay, here's what our site's going to look like. Here's where the driveways are. Here's where the building is. Here's where a detention pond is or whatever. When they have specific layout, then we go back in and we do specific explorations for the specific elements. So if we know where the building is, we will drill specifically in that area now and concentrate explorations, because we know this is where the major load is going to be on the site, because this is where the 5-story building is going to be. This is where the parking garage is going to be. This is just a driveway. It's just asphalt pavement. This side is just landscaped lawn. We don't got to worry about that side over there. So once the design team has kind of narrowed that down, and those people are usually our clients. They're the people that hire us, other civil engineers. Once we have that information, so we'll go back in and look at it again, all just to determine what's in the ground, what are they working with, and possibly what they need to work with in order to get their building or their structure, whatever their plan, in order to get that built.
That is incredible, because there are so many steps and things that have to happen and go right, so that people don't die.
Yeah.
I mean, essentially, right? Like,
yeah. Oh, that's it's not unique to civil engineering, but it weighs heavily on civil engineers in terms of the worst case scenario is potential loss of life.
Right. I always talk to David about this too.
Yeah.
As a structural engineer.
Yeah, absolutely. And it's something, we talked about earlier, and I'm sure we'll get to it a little bit later. Yeah, we'll get to it right now, about why having a professional engineer's license is so important.
Yes.
Specifically for civil engineers.
Yes, please tell us. I know what a PE is, a professional engineering license. However, I'm sure there are plenty of people that have never heard that term before. Yeah. And can you tell us what the importance of licensing is? And
sure.
Just tell us about it, I guess.
Sure. The textbook answer for why professional engineer is important is because it certifies that the engineer in question who has done the design work, it states that that person is not just responsible for the work that they produce, but they are also responsible for the lives that work can affect. It ensures that the engineer takes the health and safety of the public into their design work, that the person designing your structure or whatever you're doing has a strong ethical background. It basically makes me liable for anything that I design, anything I put out there. So it comes with an actual, like a physical, literal stamp that when I put a recommendation out, I have to stamp and I have to sign it. Me personally sign it. So it states that, yes, I did this. This is my stamp. This is my signature. Basically certifying that I've looked at this and I put my professional reputation and my personal liability on this. Every engineering firm we have insurance that covers, potential problems or things like that. But engineers can be held personally liable if things go wrong. If you were to ever turn on a show like on History Channel or something like that, and there's a run of shows called Engineering Catastrophes.
Oh, that sounds awful. Gosh.
it really is, because 90% of them are all things that civils did wrong.
Oh,
it's a bridge that fell down, a building that fell down, things like that. Because, it's not only civils that kind of need a PE. You have mechanicals, chemicals, electrical engineers, sometimes maybe aerospace or nuclear, some of the other disciplines. But a lot of those are, at least in my experience, a lot of those engineers, if they have a PE, it's for a very specific purpose, because if they work on a very specific type of job, they have to have that. But it's not a requirement to do their job entirely. To be a practicing civil engineer, you have to have a PE. A lot of times, because it is required by law that drawings, plans, recommendations to the building department, things like that, it's required that those things are stamped by a professional engineer. So if you don't have that, you can only go so far, which is to say, not beyond like an entry level, like kind of gopher work. If you want to do any actual engineering, you have to have a PE. You have to go through the process. Otherwise, you might as well not be an engineer. You might as well not be a civil engineer. You just can't do anything.
I see. So how long after you graduated college did you, I know, because you have to have some experience before actually taking the test itself to get your PE. So how long did you have to wait to get that licensing?
The minimum, so the process is, you have to take a first test, which is called the FE, the Fundamentals of Engineering. Most engineering, you can take it any time, because you can become an engineer at any point in your life. Most engineering students take that before they graduate. Most schools will set it up where we're taking the FE this day, and all the engineers who want to take it will take that before they graduate. So when you graduate, presuming you've passed the test, you have that. You have your 4-year degree from accredited university, which is another requirement. And then you need a minimum of 4 years working experience at an engineering firm in the discipline you want to work in. So you have to go out and get some experience, at least 4 years. I took it after 5 years, because the third and fourth year I was moving and changing jobs. So I didn't know exactly where I was going to be living. Because in my 4th year of working, I was temporarily living in Indiana, even though I was going to eventually live where I am now in Ohio. So I actually waited an extra year. But anytime after 4 years, you can sit and take the test. At which point you sign up, you pay the registration fee, whatever it is, and then it's a 1-day test. It's in 2 parts. It's a 4-hour test in the morning, which is a general engineering test. That's just that everyone takes. Anyone taking the PE takes the same test. I should say, by that I mean everyone per state. The test is a little different per state.
Okay.
So I am registered in Ohio.
Okay.
So that means I'm licensed to practice engineering in Ohio. I can work in other states, but in order to stamp anything, to officially give recommendations or anything like that, I need to be licensed in those states. So I'm in the process of getting my Kentucky and Indiana licenses, because I live in Cincinnati, which is in Southwest Ohio, and I work in Kentucky and Indiana and Ohio. So to have those 3 states is important. So the tests are state specific. But again, the morning test is general engineering, 4-hour test, and the afternoon test is a 4-hour test that is specific to whatever you're looking to do. So mine was civil engineering. If you're a chemical, you take the chemical test, electrical, whatever it is. So it's a pass-fail test, and you can take it as many times as you need to take until you pass.
So I mean, David has not yet prepared for this test, but we know people that have, and from what I remember, it was a pretty like serious undertaking as
It
far as
is. It is.
studying.
Yeah. The 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 well, the hardest part that I found personally was studying again
Yeah.
because I you when you're in school, it's easy because you're in the bubble
Right.
of academia. So you're just used to, you've been doing it your whole life. You go to school, you go to class, you come home, you do your work, you study, you know how to read and process material specifically for taking tests.
Sure,
You
yeah.
know, because how oftentimes you study, if you take a test, you take the test, and as soon as you leave the classroom, you forget everything.
Exactly.
Because you study specifically for the test, not to actually retain any knowledge. So you get out into the real world for 4 or 5 years and you work and you lose, at least I did. I lost all of those study
Mm,
skills, like how to just to sit down and go through and read chapters and like take notes on stuff. Because part of my mind is like, this stuff's useless. You don't need this stuff in the real world,
mhm.
or, and also because you're taking for me, it took a general civil engineering test. That means I'm taking stuff on structural engineering,
Mm,
transportation engineering,
mhm,
like land surveying. Like I'm not a
mhm.
land surveyor, but you got to study this stuff. But I've spent 4 years specifically being a geotech. So I could ace through the soils questions, but
Right,
when it gets
right.
to a structural question, like I don't know. And it's all open book, which is both good and bad because you get people walking in there like they're wheeling in these big suitcases full of every textbook because you can use any reference you want.
Oh, really? That's
Yeah,
interesting.
but it doesn't help if you don't know where to look.
That's
You know,
true.
if you have 8 books, if you have 8 books on structural engineering, that doesn't help you if you don't know which book to go to when you get
That's
the
true.
question. So it's kind of paralysis of choice there. So I know I brought every book in my library. I didn't use all of them,
Hmm, hmm.
but just in case because you never know. But that was the hardest part for me, just like forcing myself to study because like you hadn't been doing that, you know.
Yeah, yeah.
Uh, so yeah, that was the hardest part to get back into. So once I got through that and over it, it wasn't so bad. So
So, well, thankfully you did it successfully, right? Did you do it right the
yes,
first time?
took 2 times.
Well,
Yeah,
better late than never. No, I'm just kidding.
yeah. Took 2 times through. The first time and this is a little bit of the uh, thinking I knew how to study again. The first time I went through, I was like, yeah, no, I can read the stuff. I go through it, and I was studying in a way that I thought I was retaining information because I was
Uh-huh.
like, yeah, I've been through school before. I don't need to really study this stuff.
Uh-huh.
And I didn't like really apply myself to studying because I was like, I know what I'm doing. I've taken tests before. This is no big deal.
Yeah.
And yeah, I wasn't ready for it because I didn't I was a little overconfident. I was like, yeah, I was coasting on how good I thought my skills for school still were, and that was a mistake because all those skills had completely gone out the window. So the
So
second time
the
around, I really I gave myself a schedule. It's like I got to study. I got to go through these chapters
Oh,
as if
okay.
this is like I'm actually in school. So yeah, the first time around was if I had applied myself the first time, I'm sure I would have passed. But I was kind of like, yeah, I got this. This is no big deal.
Okay,
Um,
so definitely it is a rigorous test because
yeah, you have to be
clearly
ready for it. Yeah,
you have to be ready for it. You
yeah,
can't just be
yeah,
like, "Hey, I got it." But
yeah,
so listeners, advice, if you're going to take the PE, do it right the first time. I'm just kidding.
yeah. Because it's another however much to pay for the test again. So yeah.
Well, talking about, your studies, can you take us back? I mean, like, did you always know, hey, I'm going to be a geotechnical engineer? That's hard for me to believe, but I want
No,
to
I
know
didn't.
everything. I want to know it all.
I took a. The only thing I did know was that I was going to go into engineering of some way,
Mm-hmm.
and that's a little bit because I'm sure you've talked about this with Alicia and Tony in previous episodes, but as we mentioned, pretty much everyone in our family, every male in our family, not just on our side of the family, which for me
Mm-hmm.
is my mom's side, also on my dad's side of the family,
Yes.
everyone's an engineer.
Yes.
Everyone is in some form of engineering. And I bet if we pulled everyone together, we'd probably hit almost every major discipline throughout my extended family. So And a lot of that comes from, I was good in math and science, and I enjoy math and science. So it seemed like a natural segue, but I wasn't entirely certain kind of what specific discipline I wanted to go to. So when I was looking at colleges, I wasn't looking specifically like, oh, I got to find the best engineering program. I gotta find or the best chemical engineering program or the best electrical engineering program or computer engineering. I was just for me going to college, I went to the University of Virginia. I picked a place that I just wanted to go to school.
Right.
Because as important as I think, specifically in engineering, as important as your undergrad degree is and what your degree is in, you're going to learn the same stuff in any school. This has been my things that I've learned now that I've worked out in the, for several years now, and you meet other engineers, and like the people you work with, like they don't all go to the quote unquote best engineering schools. They go all over.
Yeah.
The principal engineer in my office, the guy who's got 40 some odd years experience, he went to some tiny ass school, like this really podunk school in Indiana that I've never heard of. But the guy's great.
Yeah.
Like he knows his stuff, because so much of what you have to do is actual experience. So education's important. What you learn is important. I said you're going to learn the fundamentals pretty much anywhere. Specifically when it comes to the civil discipline, I believe. So when I picked going to school at the University of Virginia, it was pretty much like I visited. I was like, this school is awesome. I want to go to school here. It was less about this is the best program for me. It was I want to have the experience of going to college here. So the academics weren't like, well, it's a great academic school. When I first told my parents I wanted to go to school there, they're like, well, University of Virginia, I've never heard of that. Why do you want to go to school there? And I was able to tell them, well, listen, if you look at the U.S. News and World Report's rankings, it's the #1 public university. And then they were like, oh, really? It's the #1 public university? Well, then you should go to school there.
Yeah.
So once I sold them on that, so the academics it's a great school, but it's not a great specific engineering school, So for me, it was just the experience of going to college and wanting to be in that place. So when I'm there, at least at UVA, all first-year engineer students, you're all thrown in. You don't specialize in a discipline until your second year.
Okay.
So your first year, your first 2 semesters, it's just all general stuff. Everyone takes the same stuff. You take calculus, you take chemistry, you take physics. It's the same stuff that everyone takes. And really, it's a way to kind of weed out students, like people who don't want to, maybe engineering school wasn't for them. So it's a year of kind of weed out. So that's just core math and science stuff. And then you declare a major after your first year. At the end of your first year and you're starting your second year, you start taking major specific classes. And I still wasn't 100% certain where I wanted to go. So I actually started out as an electrical engineer. So that was my first semester of my second year. So my third semester in college, I'm an electrical engineer. And I hated it.
Why did you hate it? What made you hate it?
It didn't click with me. I thought it would, but it really didn't click to me. I didn't engage with it. And as a result, didn't go to class much.
Okay.
Didn't go to like that. That's an overstatement to say I didn't go to class much. I wasn't into it. As a result, that third semester was academically the worst I've ever done in my life. Like legitimately the worst I've ever done in my life. And at the end of that semester, really had to kind of do some soul searching and try to really hone in on what I wanted to do, what I liked to do, what it is I liked about engineering. And what I came to was really the practical use of engineering, like really in a real world situation, not in a lab. Like Tony, my brother, he was a chemical and a biomedical. He's a lab rat, He liked working in a lab, working in that kind of section there. I like the practical use of engineering in the world. And so that leads me to civil engineering because we're constructing and building things. So that's how I got onto a civil track. And as I got into the civil track, then things started to click in terms of, okay, I'm now engaging with these classes. I'm much more attentive in class because I'm seeing how this stuff can translate and how kind of the things I'm good at, the way I think and the way kind of my mind is set up is organized in a way that works towards civil engineering. And what I mean specifically by that is I think very wood spatially in terms of how things fit together. The joke I use is I'm really good at building Lego. I love building Lego sets. So how things fit together. Any sort of logic puzzles like tanagrams, things like that, shapes fit together. I'm the best person at packing a car. If you're going on a trip or you're moving, how things fit together. I think very good space. I'm a really good Tetris player. I'll put it that way.
Yeah.
I'm the best Tetris player I've ever met. I've never met anyone who's better at me because I see how things fit together. So spatial relations and how things fit together, just that clicks with me. So when you're thinking about civil engineering, you're thinking about how roadways and buildings work together, how utility lines fit together. It's city planning, it's land planning. And so that's kind of the direction I was going in. I liked the idea of site planning, whether it was landscape planning, like site grading, whether it was city layout, like roads and bridges and things like that. So I was in kind of a dual path, going kind of a soils route, a geotechnical route, and also a transportation route, like roadway planning and city planning and things like that. And I thought I was going to be a transportation engineer, the person that goes out and lays out roadways, highways and roads, intersections, stoplight timing, things like that. I thought that's where I was going to go because I liked that logical layout work. Those classes ended up being kind of boring. So I took those classes and just realized that's not kind of what I wanted to do. So I moved away from that. But that's where I thought I was going to go in civil. And I moved more into the geotechnical civil site survey, which was the overall site planning, layout, site design, which is where your driveways go, where your drainage goes, where the building goes on a site, things like that. Everything on how to lay out a new construction. That's the path I went down. And then the first job I got out of school was with a geotechnical firm. And once I got into that and really started working with foundations and soil engineering, I've stuck with it. So
That's so interesting. I'm like, because, okay, what I'm thinking about as you're talking though is the amount of self-awareness that you had during those college years to kind of even realize that, you know what, this is not for me. I need to figure out what is for me, and identifying the things that you enjoy doing. I feel like that's that a lot of people miss that mark because I think, or at least my personality, I think I always felt like I'm committed to this thing and I'm just gonna go for it. And it's almost like, even if this mentality of like, oh, maybe I don't like it now, but maybe if I push through, I'll eventually like it. Do you know what I'm saying?
I do, and I have part of that as well. And and I'll be honest, I only came to that realization in school because that semester went so poorly, because I was so disengaged, because I really was kind of at rock bottom in terms of academic career. Like I came close to failing out of school, which
That's
I had never done
shocking
before.
for me.
Because I was so disinterested in what I was doing. So I had to make a choice and to say, well, I can't keep pushing through here because clearly if I do another semester of this, I'm not going to like it.
Right.
So had I not reached that point where, I had a big sit down with my folks as well. And I remember my dad just being like, you need to figure out what you want to do because you can't keep doing this. And in my mind, I'm thinking, well, yeah, of course he's right. I can't keep doing this because I can't stay on this track. If I knew before the first semester was over, partway through, I knew I wasn't into this, But while I was in it, I wasn't thinking about what I wanted to do else. I was just thinking, I don't want to do this. And as a result, my grades just plummeted. So once I hit the bottom, then you have to have that self-reflection of, okay, well, like, I got to figure this out because, like, I put myself in a position where I have no other options now. I need to figure out what it is I actually want to do. Because at that point, I didn't really know. All I knew was I didn't want to go down this path I was on.
Right.
So it wasn't like I had other paths in front of me. It was just the one I'm seeing is just a dead end. Right. So I got to find another one.
Right.
So that forced that self-reflection on me that otherwise I wouldn't have gotten to, which is not something I recommend. I don't recommend almost failing out of school and then being like, hey, wait a minute, maybe I should figure some stuff out here. I don't recommend anyone do that.
Yeah.
Try to figure that out earlier. And, so even if you're not totally right, you can be on the right kind of track, which I was just not. So, but once I got there and things started to click, like I said, I really started to engage with the material I was working on and doing in school, then things turned around for me and a path became clear. But in the moment, it sure wasn't.
So, in college, is there so there are specific geotechnical programs or?
Yes, some schools have that. So similar to, I think, what David has is what I have. I have a degree that says civil engineering. My diploma just says civil engineering. That's it. There's no statement of what your concentration was, what your focus was, things like that. All that comes in the specific classes that you choose.
Okay.
So you can choose, if you want to be a structural engineer, you can take all the structural courses. If you want to be an environmental engineer, you take all the environmental engineering courses. So that when you graduate and you go for a job interview or whatnot, they're going to ask you what kind of classes you took, and you can tell them that. So
Okay.
the civil engineering gets you into a civil engineering firm, but you're gonna talk to the people and apply to a job of the things that really only you know. I know I took these courses. I know I have familiarity with these courses, but that's not listed, officially anywhere. Like, I guess if you got my transcript, you'd see what classes they were. But my diploma just says civil engineering.
Right.
But I took the courses that were in civil engineering, materials testing, construction engineering, things like that, things that are all adjacent to my field.
I see.
So I'd be ready for any job that was in that general direction. I'd have the knowledge base from an academic side, at least, a basis of knowledge. So when I get into the workforce, I'm not things aren't completely foreign to me.
So you mentioned earlier too that you like math and science. So when you're doing testing of soil and materials, is that lab work?
It is. Earlier in my career, as most engineers will do, you'll do everything. So you'll be out in the field, actually doing field work. You'll be in the laboratory, actually doing tests on soil materials. I don't do that as much now as I've had more experience there, but it's the kind of thing that it's the kind of experience that you need so that when I go out into the field, when I have to go out in the field, or when I talk to the guy who runs our lab, I know what I'm talking about because I've run those tests myself. But going back to this, the science and the math basis, it's a bit of the conundrum when it comes to engineering that you have to take all these high level math courses. And the highest level math I do any day is like basic trigonometry.
Okay.
like I had to take calculus and differential equations and nonlinear algebra, and every engineer takes that stuff.
Yes.
And when you're in school, you have a graphing calculator that, to do all this stuff and all this. When you take the PE, you have to have a standard non-graphing calculator, like the basic $5 model you can get at Walmart, because that's the highest level math you have to do. And in school, you have to do all this math, no calculator. A lot of places, no calculators. You have to do all in your head, and it's like you got to memorize all this stuff. And you get out in the workforce, and you're like, right, I can use a calculator. Of course I can. So I don't trust myself to add two numbers together, 55 and 28. I'm going to make sure I do that. I put that in the calculator because I don't trust myself to do that math in my head anymore. So you have to have that base to get into it. But when you're actually the actual, my day-to-day stuff, I'm not using high-level math or anything like that. But it's just, I guess it's more of a way of thinking, having a kind of logical mindset, a scientific method kind of mindset of trial and error, testing, hypotheses, things like that. Just having a mindset and approach to everything, even if it's not the highest level math that I'm doing, highest level science that I'm doing, it's the same approach no matter what.
That makes sense. I understand that now. Speaking of your day-to-day, what does that look like? I mean, you mentioned before that you do go out in the field and things like that, but what does a typical day for a geotechnical engineer look like?
A typical day for me is going to be a combination of a couple things. One is either writing or reviewing reports. So a project that I'm in charge of that I have looked over and managed, I'm going to write up recommendations for whatever they're building, whatever they're constructing. So it's writing a report, and that gets off to another engineer who's going to review it. When they write something up, I'm going to review that as well. So everything that we get sent out, at least 2 eyes have looked at it. So I'm either writing or reviewing a report, and all that's basic office work. Sitting at a computer and writing or reading reports. Also reviewing field reports. I mentioned we have guys out in the field. Those are technicians who are out doing testing during construction. So my job as an engineer, all of our explorations, things like that, I mentioned they should take place before any actual construction is done, before any equipment has moved on to a site, before they've done anything of what they're planning to do. We should get out there and do our testing for the engineering aspect. Once they do start construction and they start moving earth, placing concrete, putting up steel or anything like that, we typically have a representative from our company out on site kind of doing third-party monitoring, making sure that they're doing what they're supposed to do. Every construction job has a specification book saying that the soil has to be this, the concrete has to be this, things like that, to make sure that the building is built properly. Because there's some contractors that are, they're going to want to cut corners. You're going to do things that are cheaper and faster and things like that. So we come in as a third party and watch them. And we take periodic testings and things like that. So we have a guy outside doing that. And then I, as an engineer, are going to review that and make sure that, okay, here's what we got to, make sure that they're on site collecting the data. They're running the test in the field. And then I look back at it in the office and say, okay, well, this is good. This is good. Hey, this is a problem. What happened on this day? This test is bad. What are we going to do about it? And we bring that up to the client and say, okay, hey, on this day, the soil that you placed is no good. It's got to be, you got to address this somehow. So it's my job to look at that before the report gets officially issued. And all that office work, that report reviewing and writing, that's all like 65% of my job. The other 30% is actually going out on a job site. Because like I said, we have a technician on site. But that guy, may or may not have a degree in anything engineering wise. It's a guy that's out there kind of doing the physical work. So he's my mouthpiece on site. I'm talking to this guy. There's an issue on site, and he'll relay back to me, hey, here's what I'm seeing. Here's what the tests are saying. Here's some pictures of all this. And I can talk to him and say, okay, here's what my recommendations are. But sometimes the people on site, they want to talk to the actual engineer, me. So I have to go onto a job site, and a lot of times it's walking out. It could be 5 minutes. Walk onto a site and be like, nope, this is terrible. You got to fix it. This is what you got to do. Which is what I could have said over the phone, but sometimes you have to actually be there. So I got to visit a job site and actually kind of be the voice of authority, because as a professional engineer, what I say goes.
Yes.
So I got to be on site and deal with that and be able to communicate with that with the people on site, with people with varying level of experience. Because a lot of these guys who are moving earth and all that, they could be doing that for 45 years. The guy's been on a bulldozer since he was 18, and he's been doing that his whole life, and he knows what to do because I've been doing this my whole life. And I got to come in and I got to be the guy who comes on site and be like, hey, well, no, that worked before, but maybe it doesn't work now. So you have to be that voice of authority to see when things come up that are that require kind of specialty attention. And as homogeneous as some sites are, like in Greater Cincinnati, I know if you're in a certain part of town, I know what the soil is going to be like because I've worked there enough.
Yeah.
If it's a 2-story building addition on an office building or something like that, like I know what to expect if it's in a certain part of town, whether it's on the east side of town or the north side of town or something like that. I know what the soils are going to be because I have the experience. But every so often you get a site that requires special attention. And so, to do my job better, I have to actually see what's there. If I can see what the soil looks like, if I can see what the rock looks like, if I can see what the ground is doing, all that information is helpful to me that I can't just get from looking at soil samples in a lab or looking up at a geology map online or something like that. So you have to get out in the field. You have to see what's going on to really have a handle on what's happening.
Yeah.
So, I have to get out in the field sometimes. I got to get out there and literally get my hands dirty
Yes.
to know
In
what's
your
going on.
case.
Yeah,
Yeah.
yeah, actually, which sometimes that means, tromping around in the woods or walking through a swamp or something like that,
Oh
which isn't the
gosh.
best days, but,
Yeah.
sometimes that's what you got to do. I've done that plenty of times.
I mean, so it sounds like you enjoy what you do.
I do. I do. Yeah. There is, you mentioned before how, engineering soil and earth is something you never really considered that had to be done. And that goes for the vast majority of people in the world.
Hmm.
They don't think about, and really, if I've done my job correctly, you shouldn't think about that. You shouldn't think about
Right.
how your road goes, if your building is stable, if your water line is straight and aligned. You shouldn't have to think about these things. So I get satisfaction driving around town. Like I can drive all around town and see projects that I've worked on, that I've done,
Mm.
buildings that I've done, structures that I've worked on, and I get satisfaction out of that, knowing that it's up there and it's good and it's solid and it's not going anywhere.
Yeah.
So I do enjoy that because it is my work only gets known when something goes wrong, you know,
Right.
because uh, the perception is no one's life is better if I do my job correctly. Their life just functions as they expect it to.
Mm.
Like your life
I
isn't.
guess. Yeah.
Like your life isn't improved if your building is stable. You expect your building to be stable.
Yes, I
It,
do.
it
I
isn't.
do
It
expect
isn't.
that.
It
Yes.
isn't an added benefit that your building is not moving, that your roads aren't breaking and falling apart, or sinking and settling and all that. That's what you expect it to be. It's only when things go wrong that your building has cracks in it. It's settling. Your roadway has cracks in it. It's settling. Your retaining wall is sagging and falling down. Your slope behind your house is giving away, and you're losing your backyard or something like that. Only when things go wrong do people have an understanding of, wait a minute, why is this going wrong? Who do we call to fix this?
Yes.
So there is a little bit of I don't want to say gratitude, but it's just there is a kind of a mundaneness to my field of civil engineering, of just, this is what has to be done so the rest of the world can function as properly.
Yeah. Would you say like that's what you love about your job? Like because I mean
Yeah,
it's vital, you know?
yeah. Yeah, well, I like being part of building infrastructure, because infrastructure is what makes the world go.
Yes, it
In the
is.
most basic sense. Having roadway network, having utility network, things like that. So, no, I said I get satisfaction driving around town and being like, yeah, I worked on that building there. I did this roadway here. That retaining wall, I built that. I designed that. I get satisfaction in that, and knowing that they're functioning properly, and that
Yes.
and that they're not causing harm to the surrounding people in the surrounding areas. That I've done my job, properly. I've done it correctly, and thus it goes unnoticed. That you just see a 40-foot retaining wall, and you don't think anything of it because it's not cracking, it's not leaking water through, anything like that. It's just there, and you drive by it on a road that you're not thinking about because it's just there. So
Right.
yeah, I take satisfaction in having kind of a hidden hand in the world we see.
No, definitely. I mean, okay. So David might not like me telling people this, but it's okay. I mean, I kind of make fun of him, honestly, because, this engineering, so I guess, nerdy side of him, like he'll go by things and like, oh, he'll be like, hey, look at that building. Or like, oh, wow, that's really cool. Like, just like the structure of it, if they're just starting to build it, because he
Yeah,
knows what's happening, right? And I'm
yeah,
like, great, yeah,
yeah.
cool. But then
Oh yeah,
kind
no,
of roll my
that's
eyes. But
that's
like,
a that's a
I,
fairly common trait amongst specifically civils. Anyone who works
yeah.
in construction, when you drive by something like that, whether it's in construction or when it's finished, yeah, no, I notice things all the time.
Yeah, and
Absolutely.
like I kind of like roll my eyes, make fun of because I don't know that side, but I appreciate that side, because I'm like, yeah, that's cool that you like your job that much. But I'm curious, like, at the risk of sounding a little bit silly and ignorant, like, do you look at soil and are you like, huh, interesting, like that?
Uh, 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 yeah, sure. I'll answer truthfully. Yes, I do. It is because I find it interesting. Because the thing about soil and earth is that the part that I find interesting is that it has history. Soil remembers everything that's ever happened to it, and I'm not just talking about a building that might have been there 50 years ago. I'm talking about the 2 foot thick glacier that was there the first ice age, or the 2 foot thick glacier that was there the second ice age, or the ancient riverbed that was there that left sediment there, all those years ago. All that, it remembers all of that. So the weight of that giant glacier, the soil remembers that weight even though it's long gone. That amount of pressure, that amount of weight is still present there, and that affects the characteristics of that soil. So knowing geology of an area, knowing what happened before, is critical to how I do my job today. So I find that stuff interesting, knowing what was there before, and depending on where you are in the country, it varies wildly. So I went to school in Virginia, and the first part of my career working was in the state of Virginia. Virginia has 6 very specific geographic zones, kind of moving east to west. So depending on where you are in the state, you can get wildly different conditions, just because that's how the state was formed, how the landmass was formed. And so it presents challenges depending on where you are. There was one project I remember right in downtown Richmond. I worked in Richmond, Virginia, the capital of Virginia. And we were building a new federal courthouse downtown. And it was right on one of these kind of geographic changes. So the west side of the building, bedrock, solid bedrock, was about 5 foot deep. So you dig down and you could build literally anything on that. It's super solid. It's right there. That was the west side of the building.
Okay.
By the time you got to the east side of the building, that bedrock falls off. And the east side of the building is on sand, and bedrock is over 200 feet deep. So basically you can't find bedrock now. So this one building has had to have different foundations for each side because the conditions were completely different, because it happened to fall right on one of these different geologic lines. So challenges like that, and knowing something like that, to me, that's interesting.
No,
it's a pain. It's a total pain to try to design and to actually build, because you're talking about simple shallow footings on rock. This rock is hard to hold anything on this really kind of loose sand. You have these 50, 60, 70 foot piles that go deep into the ground to try to support it. It's a challenge like that, and those things are rare, but they exist. But you only get that in a place like Virginia, where you have those kind of geographic differentiations. If you go out, west, California or Arizona, something like that, your soil conditions are totally different, and what you have to deal with over there is completely different than what you have to deal with, like where I am in Ohio, which is why the PE license is state specific, because you're dealing with different things. Like in California, obviously you got to worry about earthquakes.
Yes.
Seismic activity is critical. So what do you do to design for that? Your tolerances for movement in the earth due to earthquakes and whatnot are a lot different than if you live in Ohio, where, yeah, we may get an earthquake here or there, but it's really, really minor. But it's a big earthquake for us because we don't have earthquakes. It's like an inch of snow isn't a big deal if you live in Minnesota. But an inch of snow in Texas, in Atlanta, an inch of snow in Atlanta will cause 200 car wrecks in a day.
Yes, yes.
So a 3.2 earthquake in the Midwest is a big deal, but like a 3.2 in LA, like they don't even feel that. That's nothing to them. So where you are in the world will change your approach to how you design footings. So yeah, when I go someplace new or someplace different, I'm always curious as to what the conditions are. I like to know what the challenges are for an engineer in the other part of the country or something like that. So yeah, something like that is interesting to me. The different types of soil, the different types of rock. Yeah, I like to know because I'm a nerd like that.
No, I mean, I love that. I think that's so cool. Maybe I'm a nerd too, I guess. But because even that story you're telling about, you know, in Virginia, how you had to build on two different soils on the same building, like that's crazy to me. And I
Yeah,
love that kind of history. And I thought it was really interesting that you were saying that. I had no idea that soil could tell a story. Like
yeah, 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 yeah.
crazy.
Yeah, so it was this soil placed there? Was it wind blown? Did it fall off a cliff? Was it placed there by some sort of waterway, like a river or a lake that's not there anymore?
Right.
All those things will contribute to how it's going to act now. Like if there was an ancient lake bed somewhere that's now dried up, well, the soil that was there will is placed in a way where it just settles at the bottom. You put soil in some water, like
Uh-huh.
like a beach pail or something like that. It'll eventually settle on the bottom,
Uh-huh.
by its own weight through gravity. But it's not going to settle like real compact. It's going to be kind of loose, or depending on what the soil is like, it'll settle at different rates. So sand and gravel are going to settle a lot faster than silt and clay because they're bigger, heavier pieces. So if something settles in water, it not only will settle loosely, but it'll settle in layers, or it can settle in layers. So all that information tells me about what I'm going to expect when I try to build something there. So I have to know that because that will affect my recommendations. If I know something is a material that previously had a glacier on it, well, no building I'm going to put is going to equal the weight of a 2 mile thick ice glacier. Like that soil has already experienced the greatest load it's ever going to experience. Nothing will ever top that. So I know that soil is really solid. It's really stiff, and can take a lot of weight, and isn't going to be as variable as something that may have just been like wind blown or deposited there by water, where it just settled on its own,
Sure,
or it could
yeah.
be real loose and very compressible. So all those things, yes, it does tell a story. It tells a story of what was there before, and that can even go to if this building, like if you're in an urban area, buildings are going to be built and demolished 2, 3, 4 times over. So if a site already had something there before, I want to know what that history is. Did it have a basement that was filled in? What was there before? Was it an old brick building? Was it an old stone foundation? Something like that. So, history isn't just millions of years ago. History is also like 40 years ago or 50
Yes.
years ago.
Yes.
All that stuff matters.
That's crazy. So crazy. Is there anything that you just like don't like about your job that you can share with people?
Yes, and it's not something about the actual job itself. It's about the industry of the job.
Okay.
My industry is too often based on a cost basis. Projects get awarded too often basically on who's the cheapest, not who's going to do the best work,
I see.
which is a problem, because if there's one firm that's really cheap on their price, you should be asking yourself, why are they so much cheaper than someone else? So it's not about what you're getting for that price. You should be asking, what are you not getting for that price? Because in the grand scheme of things, there's not a lot of money in geotech engineering. The profit margin is very small. I don't make a whole lot of money. I make a living, but I don't make a huge amount. But in the grand scheme of things, overall to a construction budget, the specific geotechnical engineering portion of the budget is really, really small. Like you could be spending $500,000, $1 million on a development, and your geotech budget may be like $20,000. That's all it takes. So, you got $1 million in your budget for an engineering fair. It's going to be like $20,000. Well, but instead of spending $20,000, they're going to go to the firm that spends $15,000 and save themselves $5,000. Okay, you save $5,000, but you're spending $1 million on this.
Right.
You know, and if you save $5,000 and something goes wrong, the cost to fix it is not $5,000.
Yeah.
The cost to fix it could be $50,000 or
Right.
$100,000. So we try to tell people you have to weigh the idea of spend a few extra $1,000s now so you're not spending hundreds of $1,000s later. Because the further you go in construction to try and fix a problem, obviously the more expensive it's going to be. So if you can find things up front when nothing has been done, by spending a little more extra money on a firm that has experience, you know, you can save yourself money down the line. But they don't think, a lot of people don't think that way. They're thinking, well, if I can save $1,000 now, I'm good. Well, that $1,000 could cost you 20,000, 30,000 later. And so that's a frustrating part, especially when, like, I just submitted a proposal that had to include a statement of qualifications package, which is saying, here's our firm, here's all of the work that we've done in the area you're working in here's all the projects we've done that are similar to what you're trying to build. Here's everything that we've done, all the experience we have with our engineers, our lab. Here's everything that we do that we can bring to your project. And I found out that we didn't get the project because the client just went on price. And I thought, well, if you're just going to go on price, then why am I submitting all this stuff? Why do you care about what our experience is if you're just going to flip to the end and be like, okay, well, they cost 10,000, they cost 12,000, they cost 8,000, we're going to go with the 8,000. Like, what was the point of all this stuff? What's the point of having all this experience if you're just going to go on price? And that happens too often. So that's a part of the industry I don't like, because it gets to a point where there are not a lot of firms that do this stuff. And so it's a pretty small community. So anytime a bid goes out for a project, like, I know who's going to bid on it. And it's not just I know the firms, like I know the actual people. I know the other engineers at other firms. I know my competition because I've worked with them on stuff and against them on stuff. So like you just know, well, if it's a certain project from a certain client, like sometimes we don't even bother bidding on it because they're not going to pick us. They're going to go with who they know who's cheap, you know? And so it's like it's not worth the effort to try and do this because we're going to put all this time in to try and put this bid together that's really attractive and really good for them. And they're just going to ignore it and be like, we're going to go with these guys because they're cheaper.
Right.
And that's a bummer. And that's the part that there's nothing I can do about that because you can only cut prices so much.
Yes.
You know, if you cut prices so much, you can't deliver a quality product. And all that comes back to having a PE stamp. My name is going on this eventually. My stamp and my reputation is going on this. So if it's going out with my name on it and my reputation on it, it's going to be good. It's going to be worthwhile. I'm not going to cut corners by slashing my price down and intentionally reducing my ability to do my job just so I can get a job, just so I can work on this project. I'm not going to do it, you know, at 50% just to win it.
Right.
Because I got to put a stamp on it. And there are some engineers that will do that. Obviously, there's someone that'll, you know, they'll cut costs and they'll kind of take that loss to get more work in. And I don't think that's a viable business solution, but it's a part of the industry that we just try to change and be like, listen, like these guys, maybe they'll be fine for 3, 4, 5 projects, but the one project that they screw up on because you went with price, that one project could cost you a whole lot of money on the line. You know, so you know, we try to get that across to clients, and some are receptive to it, and some are just they're just looking at the bottom line. So I hate that so much of my job comes down to how much it's going to cost somebody, and not the service I can provide you. That I'm going to give you something better than my competition, something that you can rely on and not have questions on and not worry about down the line, because it's a quality product that I stand behind. The industry just isn't geared that way.
I guess I'm naive to think that people wouldn't want, especially when it comes to buildings and structures and bridges and things like that, like and walls, that they wouldn't want, you know, to get what they pay for.
Yeah.
But
Well, that's the thing. They pay for it. It's just a lower quality.
Right.
They don't want to pay for the higher. But that falls back on the engineer in terms of wanting to have the public safety and public well-being in mind. If you're a developer who's building an apartment building or whatever, or an office building, what you care about is getting the building up and getting tenants in it so you can make money off it, because it's a for-profit business. You're trying to make money. Nothing wrong with that. But yeah, they're not thinking about what's best for the building or the actual construction of it. When you're developing, all you're thinking about is the end product. You know, we don't expect people to have a knowledge of civil engineering, of geotechnical engineering, of landscape engineering, of structural engineering. You're not supposed to know that stuff. You're supposed to hire people that know that stuff.
Yes.
So they do, but they should be hiring the people that provided the best service, not the cheapest service. And that's the problem that happens. They know they have to get these experts. They have to get people who know what they're doing, but they're not judging that based on they're not often enough basing that decision on actual experience, actual quality.
Yeah.
So if I could change one part of that, would be try to change the industry from cost-based decision making to, you know, merit-based, product-based industry. But that's something that'll never change. There's nothing you can change about that. That's just how it is. So.
Sounds like a constant struggle. I will say you are not my first guest to share with me that one of the downsides to their jobs is the money, you know, like
Absolutely.
You know, just money being the bottom line, whether it's like a governmental job where they have to answer to somebody that has the money and things like that. So I'm learning a lot.
The end result is I work for somebody. Someone has hired me to provide them with a service. And so, you know, it isn't like I go out on my own and do this stuff. I'm working, even if I give them news they may not want to hear, and I tell them their site's terrible, they can't build on it, I'm still working for them. So I have to be hired by someone. So I have to get someone to pay me money to do the job that they are legally required to have me do for them.
Yeah.
So the burden that falls on them is, well, I have to get this. So if I have to pay for it, I'm going to pay the least amount for it. And that's their mindset. And that's the barrier you got to overcome and be like, well, no, the reason you have to get this is because it's critical to your development. It isn't, you know, the building code isn't such, they're not being a hindrance to you saying you have to have these engineers here. They're saying for the good of your construction, of your project, you have to do this. But bottom line is what it is. And that's the barrier you bump up against time and time again, that you just, sometimes you got to throw your hands up and be like, well, listen, this is the best we can do. We can't go any cheaper. You know, if this is what it is, this is what it is. And too often we've done that with clients where they say, hey, could you guys go a little cheaper on this and do a little less, and be like,
negotiating.
No. Okay, this is not negotiation. If I could do less, I would do less, but I can't. This is what I have to do to give you what you need. This isn't something I can, you know, like I'm not adding stuff just to make it more expensive. I have to do this amount to give you what you need. And if you don't want that, and you willingly want to go somewhere else, you know, so be it. You know, I can't fight that, because I said it's not a negotiation. This isn't. We're not bartering with services. You're saying I need your services, and I'm telling you this is what you have to have, and it's take it or leave it. And like I said, I wish more clients were more receptive to, hey, this is actually critical. And the ones that know that are the ones that have been burned in the past. You know, the ones that had to, you had to pay an extra $500,000 in this project because someone screwed up, because you didn't do it right the first time. And those jobs are always, I mean, from a financial standpoint, those jobs are good when you got to come back in on the back end and fix someone else's work. Because,
oh gosh.
It's bad because that means something's gone wrong.
Yeah.
But it looks good on you to be like, well, yeah, if you'd come to us the first time, you wouldn't have done this, you know?
Yeah.
But, you know, fixing someone else's work is both good and bad, because there's always more money in that. But it also means that something has gone wrong. Something has failed, which shouldn't have failed the first time.
Yeah.
I whenever we get a job like that, it's a mixed blessing of, hey, this is great. I love this kind of work. But it's also like someone's house could go if we don't fix this very quickly. You know, if we don't fix this slope soon, this whole subdivision could be gone.
That's crazy.
It's a double-edged sword.
That's insane to just even think about, really. But we are coming up on our time here together, and so I've been asking all my guests to share with me a little bit if you have any advice for somebody that maybe wants to get into geotechnical engineering or thinking about it, just civil in general, or just life advice, anything you'd want to share with our listeners?
Yeah, I mean, if I go back to, I mean, you're looking to hopefully kind of target high school age kids and things like that, right?
Yes.
Kids going into, what I would say is, this may not be true for all branches of engineering, but if you're going into the ones that I've dealt with mostly, kind of civil, mechanical, electrical, those kind of fields, what's really important is your job experience that you end up getting after school. The specific program that you go to in college is oftentimes less important. Like, no one, I haven't met anybody so far in 17 years as a professional that cares about where you went to undergrad school. Some places, some parts of the country, it may be beneficial to have a graduate degree, a master's or something like that, but not every place is. But even then, where you get your master's is less important, because you're getting that same base of knowledge. So if you're looking to get in engineering, this is in my mind, college is an experience that's more than just what you're learning in class. And I know that's a fine line to walk, in that college is not just about out of class experience, but it is about life experience. Go somewhere you're going to enjoy, somewhere that you're going to like to be, the environment you're going to be in, because you're going to learn the stuff that you're going to need to learn to get a job. And then the stuff you learn on the job is going to be what advances you in your career. Having the degree, having the base of knowledge is going to get you a job, but that's not going to get you anything. That job's not going to differ if you went to school A or school B, really, So if you're looking to get into engineering, just do well in school, have the grades, go to a school that you're going to enjoy being at, find a path, find a discipline you're going to like, and then don't think about your specific academics as like, this is going to this school and getting a degree from this school is what's going to get me a job, because that's not what's going to happen. No one's going to look at it and be like, oh, well, this guy went to this school, this technical school, and this guy went to the other school. No one's going to care about that. At least when I've interviewed people, I don't care about that. Interviews that I've been on, they don't care about that. Have a strong base of the fundamentals. You're going to learn those in any school. So worry less about the program, unless you know for certain, unless you're positive, I want to do this engineering right away. And you want to go to that school because you want to focus on that. And then that's more for you as a student and less about your career perspectives. You're not going to this school because going to this school is going to get you a job later. If you know you want to be a chemical engineer or something like that, and you want to go to a school that specializes in that, that's really highly rated in that, do that for you, for your experience there. Don't do that because you think it's going to get you a better job later. It's going to increase your attractiveness in the job market. Because what I found in engineering is it's all about your knowledge base, what you know, what your experience is. You're going to get that anywhere. So you're going to get a job based on how well you interview, how well you did in school. Did you get by with like D's and C's? Not going to do great in your interview there. Get a job, get that experience, get the actual experience. Get as much of what you can after graduation. That's where you're gonna advance in your career, specifically in civil engineering. Where your trajectory in your career is going to be based on what you actually learn as a professional, not what you learn in school. So worry less about the specifics of your schooling. Do well in school. Again, like I say, don't almost fail out before you decide to go in a certain direction. Still do well in school. School is definitely still important, but the specifics of where you go, your resume is not going to be led by where you got your degree from. So don't make a decision based on that. Make a decision on where you want to go to school. Place that feels comfortable. When I decided to go to UVA, it was because I visited the school and like I loved it there. It's like I want I want to spend time here. I want to be here. I don't care if it's the highest rated engineering school in any sort of discipline. This is the experience I want to have, because college is that transition point between you're like kind of an adult because you're kind of on your own, but you're still not really an adult yet. You
Yeah.
know, it's an important transition point. You learn more things about life than other than just what your career is going to be. You learn some life lessons there. So there's more to school than just the academics and the specific academics of what you think your major is going to be. Because so often you've talked to some people, like I know Alicia was one of them, was what you majored in ends up not being anything you end up doing in life.
Yes,
You know,
absolutely.
so oftentimes your major, but engineering is one of those cases where it does matter because you need that base of knowledge. You have to learn engineering to get that initial job. But the specifics of where you go, where you actually go, like I said, that's not going to lead your resume. You know, my education is on my resume, but like it's at the very end. What it starts with is where I've worked and the kind of projects I've worked on and the responsibilities I had at my job. And then at the end, it's like, oh yeah, by the way, I have a degree from UVA. That isn't important. No one cares about that. That's never been a topic of conversation on any professional I've ever spoken with. So, you know, a lot of kids worry about where they go to school and things like that. And some, you know, there are some professions that maybe that is important, you know. I think it's less so for engineers because ultimately it comes down is, can you do the work, you know? So you've got a degree from the top rated engineering school in the country. Congrats. You can still be a terrible engineer.
Yes,
You know,
I
you can
don't disagree with that.
you can still have no feel for the job. You still can't be able to do your job effectively. So that part doesn't matter so much. So if you're thinking about engineering, you know, you'll get the basic knowledge anywhere. Any student that's out there that has an interest in science and math, that has an interest kind of in that STEM focus, you know, find a school that you're going to be comfortable with, that you're going to enjoy being at, and you'll get the knowledge you need kind of regardless. And then worry about the rest of your career, the trajectory of it, when you actually start working.
Yeah, that's great advice because I want to tell people that all the time, but I don't really have anywhere to apply it to. But I mean, like, it is true, you know, and at the end of the day, you know, I talk to a lot of people, not for this podcast specifically, but even just other professionals that are around me, and they tell me the same thing. Like, no one's asking you, what was your GPA when you graduated college? You know, like, no one's
Exactly.
asking
Yeah.
that.
Yeah.
All they want to know
Yeah.
is if you did the work. So,
Exactly. Yeah. It's really important in the moment. Like, what are your test scores to get into school? Where'd you go to school? There's
right.
a mark. There are times when that can be like a false status symbol,
Sure.
but never in my professional career.
Right.
You know,
That's
it
good
only
news.
matters.
That's good news.
Yeah. It only matters where I went to school when I meet someone who went to a rival school, and by rival school I mean like athletically, you know, or
Yeah,
you know, like
agreed.
you know, for example, on a tangent, from an engineering standpoint, in Virginia, the quote unquote higher rated school is Virginia Tech. You know, they're a polytechnic institute. What they do is engineering. So technically they are a quote unquote better engineering school. So I worked with a lot of people who have degrees from Virginia Tech, not just in Virginia, you meet them all over. And they have a renowned specific geotechnical engineering program there. So I've met a lot of people who have degrees from Virginia Tech, who I've worked with all over the country, everywhere I've lived. It doesn't matter at all where we went to school when we're working. It only matters when we meet in football. You know, it only matters when we play in basketball. You know, that stuff doesn't matter when we're working because it doesn't matter where we went to school. It only matters is, are you competent at your job? When I talk to you, do I feel like you know what you're talking about? Because I have a base of knowledge, and who I'm talking to does as well. You know, if they look at me and think that I don't know what I'm talking about, it doesn't matter where I was educated from. All that matters is this guy doesn't know what he's doing. You know, that's all they think about. So that sort of stigma or that sort of, I don't know, social standing from a professional standpoint, it's never come up.
Yeah,
it only matters. It only matters in the, you know, when you're walking around like in the grocery store and you're wearing your school colors or something like that. It only matters in a social sense, to be proud of the school you went to, to rep your school in that way,
Yes.
just in an everyday basis as an alumni. It only matters in that sense. It doesn't matter into my job. It's never once played a factor in my job.
Yes, that's really great advice. Thank you so much for telling us that and sharing it with us. And thank you just so much for telling us about this industry and this field of work. I really appreciate it just from my personal standpoint as your baby cousin, because I learned so much about you and what you do today. And I know that our listeners will probably find this very insightful too. So thank you again, Alex.
Oh, I appreciate it. No problem. Thank you, Blair.
Guys, thanks for listening to today's episode. If anything you heard today was interesting, or you have any questions or want to just find out more about geotechnical engineering, feel free to reach out to me through DMs, or you can reach out to me through email at podcastwigu, wigu@gmail.com. Thanks again for listening. Until next time, bye guys.